Welcome again to our series of videos on life cycle assessments. This is the first video in what I like to think of as part 2 of this series. So part 1 was sort of our introduction. We looked at a very broad overview of LCAs from the viewpoint of ISO standards 14040 and 14044. We then looked at those standards in a bit of detail, one video for each document. We then had a fourth video, which allowed us a deeper look into the terms and definitions used in LCAs, so that we have a common language with which to discuss these concepts. Now, in part 2 of these series, we will look at each phase of the life cycle assessment in detail. This is the right time to do it. We're familiar with both of the standards that define these phases, and we have the right language to talk about them and what they each entail. So for our first stop, let's begin at the beginning with this video on the LCA goal and scope definition phase. Let's start with a bit of an overview. The goal and scope definition phase includes two major critical elements, the system boundary and the level of detail of the study. These depend on the subject of the study and the study's intended use, of course. Also, keep in mind that the depth and breadth of your goal and scope can vary considerably across different LCAs and different product systems. Let's also take a second to remember that sometimes the goal of a study can be satisfied by omitting the impact assessment phase, the LCIA, as laid out in ISO 14040 and 14044. In this case, the LCA study is better called an LCI study, to refer to the fact that the main executive phase of the study is the LCI phase, or rather, the life cycle inventory analysis. Alright, with that out of the way, let's talk about the goal definition. If you'll recall, the goal of the study is, broadly speaking, the reasons for which we are expending this time and effort. The ISO standards for LCA assert that the goal should state the following. The intended application for the study. What will it be used for? The reasons for carrying out the study. Why are we studying this product system? The intended audience for the results. Is it the public? Is it your shareholders? Is it your corporate or your R&D team? This will help determine what exactly you assess and what you will ultimately present in the final reporting phase. Finally, whether the results shall be used to make comparative assertions that are intended for public release. You'll recall from previous videos, this is sort of a big deal. Remember as well an interesting point about the LCA at high level. There's no scientific basis for reducing your LCA results to a single overall score or number. So while we may have input or output weights, and we might have averages of this stock or aggregate flow volumes of that energy source, whatever, condensing all of that information into a single overall score has no scientific basis, and in fact, it can obscure some details of the study past the point where they become helpful. So, that's the goal definition phase. It's pretty straightforward, right? In the goal definition phase, we define the goals. There are some guidelines, of course, we follow to make sure our assertions are complete and accurate, but it's a fairly straightforward procedure. Keep in mind too, if we ever need to come back to the goal definition phase because of the iterative nature of the LCA, we revisit this process we just discussed, and it is just as quick to lay them out again, just as quick as that. It's not to say that the implications of changing your goals of the study won't have deep ripples throughout the rest of the study. That goes without saying. But as far as revisiting this phase in particular, it is indeed from this simple seed, defining your goals clearly and completely, it's from there that the rest of your study can grow. Now, the scope definition portion is a little more in-depth, which we sort of expect. At this point, we are taking our goals that we've defined and now looking at to what extent will we dissect our product system in order to meet those goals. Now, this is obviously important, and you really want to make sure to be rigorous at this point. LCAs can take a lot of time and money and effort just to conduct them. And if you think about it, we're sort of caught in a precarious middle at this point. We don't want to keep our scope too narrow for fear of, spending too much, because then we might not get the data that we need to make the study carry any weight. And all that work we do will have been for nothing anyhow. We will have wasted all of those resources. But on the other hand, too broad of a scope means more time, more experts, more data processing, more resources, and more costs overall. We don't want to go overboard in that sense and analyze absolutely everything, because this is wasteful. More importantly, it doesn't give us a clear picture of the product system with respect to the goals that we're trying to achieve. This is not accomplished by drowning ourselves in data. So what do? Let's break this down a bit according to the ISO standards documents. First, the scope should be sufficiently well defined to ensure the depth and detail of the study are sufficient to address the goals. This is that basic question of balance that we just addressed. It's up to you and your team to determine what is meant by sufficiently well defined. How do you do that? Well, we also know that the scope should include the following subcomponents: the product system to be studied, that goes without saying, but also the functions of that product system, or in the case of comparative studies, the abstracted systems themselves. You want to look at the functional unit of that system, as well as the system boundary associated with it, any allocation procedures that you've come up with, and any impact categories that you've selected, as well as the methodologies of impact assessment that might include any subsequent interpretation to be used, including third-party methods you use in conjunction with the LCA. Finally, you want to look at your data requirements, your initial data quality requirements, any assumptions or limitations that you identify in the study, the type of critical review that you intend to use, if any, and the type and format of the report required to effectively communicate the results of the study. Now, this seems like a lot, but let's take a second and notice something here. Notice that within these guidelines, the scope actually helps to start building the framework from which the rest of the study itself will evolve. For example, by defining up front your functional unit and system boundary for your product system, we are narrowing our focus in that sense early on in the process. And this will help us when we go and decide which data we want to collect, or how long we want to collect it for. Things like this. By asserting things like allocation procedures, or the types of critical review or report that we expect to produce, we are providing scaffolding for future LCA phases. Now, you might recognize some of these terms because when we looked at the LCA as a whole, these are some of the major parts of setting up the analysis that we looked at. This groundwork begins in the scope definition phase. That's why we kind of take a bit of time now to kind of discuss these parts in detail. They play a big role later on in the study. Now, once again, you've heard me say it, it's important, so it bears repeating. An LCA is an iterative process, and as the study progresses, you may find that some aspects of your scope might need to be modified in order to stay on track and meet your original study goals. If you make these modifications, you have to record them, along with their justifications for their use. So, this is important. If you find that you need to change tack, don't just start a new study and throw the old one out, right? Keep track of what works, but also keep track of what doesn't work. This will help inform your study as you continue to refine it, and it can potentially inform future studies done on the same or similar product systems. We found this was effective, we found this wasn't effective. No effort should be wasted, and even ventures that you perceive as failures should still be documented for posterity, and most importantly for reference. Alright, here's a quick note about the functional unit. Now recall that a system can have any number of functions. The ones selected for the study depends on the goal and the scope of the LCA. So if you're running a restaurant, for example, your system boundary might occur where the supplier's goods come in from the trucks and the completed dishes go out into the dining room and onto the customers. If your goal that you've defined is you want to save natural gas and heating costs, okay, you'll probably want to look at your ovens, You'll probably want to look at your grills, your dishwasher, your hot tables. On the other hand, you probably don't need to look at your freezer, your dry goods storage, your produce fridge, your ice cream sundae bar. It seems like a simple example, but keeping this kind of strict delineation in mind is exactly how you ensure your scope is tailored to the precision you actually need. You're not going over or under, kind of like we discussed. Now, remember that the functional unit defines the quantification of the identified functions of the product. Its performance characteristics in plain English. How does the product system perform in a standardized way, according to a standardized metric? The functional unit's primary purpose is to provide a reference to which inputs and outputs are related. This is how we keep our flow data comparable within our LCA results, especially if we start mixing product systems. Therefore, a functional unit should be clearly defined and easily measurable. And once we choose our functional unit, we can define its related reference flow. So let's go back to our restaurant product system. We want to save on natural gas while serving our food. So we might set our functional unit as 1 meal served. Right? Some meals might need a little bit more heat and therefore a little bit more natural gas than others. That's okay, we can do some averaging, some aggregating later on, but we need to determine a unit from which other calculations can follow. So, for a functional unit of 1 meal served, the reference flow might be the allocated amount of natural gas that goes into making that dish. That sounds a bit weird, right? To make it even worse, we typically don't buy our natural gas in little convenient parcels like that, right? 1 unit per meal. We have to pay a company to pipe it into our building, or we pay to have a tank filled and we draw from that tank as we need our gas. This is something you'd have to account for. The point is, regardless of your setup, your functional unit and your reference flow will depend on and should accurately represent the set of circumstances you're currently in. They should represent a normalized unit of production that other calculations and other considerations in the study can take as axiomatic, foundational. That's why we use words like unit and reference with relation to these concepts. So, now we've talked about how flows come in and out of the system. Let's talk about the system itself by exploring the system boundary, again in the context of scope definition. Here's what the standards say. An LCA is conducted by defining product systems as models that describe key elements of the physical systems they represent. The system boundary defines which unit processes are included in that system. Any decisions made, they should be made with respect to which inputs and outputs are included in the study and the level of detail to which they are studied. So basically, our study will consider everything inside the system boundary and use the information about what comes in and what goes out to the model, to model how our product system operates. So you can see that the criteria that we use to set a system boundary is important for the degree of confidence in the results of the study and the possibility of reaching the goals we might have. So for example, the choice of elements we include in the physical system depends on a few things. For example, the goal and scope that we end up defining. Also, the intended applications that we have for our study and the audience that it will go out to once we publish it. Any assumptions that we made in carrying the study out. Any data or cost constraints that might have come into the study. And any cut-off criteria for entry into the system in the first place. We'll come back to that in just a bit. For now, let's recall that in many cases, like the scope itself, the initially defined system boundary may need to be redefined. Again, that's the iterative nature of the LCA at work. I think you probably understand the nature of the system boundary at this point, as it relates to the scope definition phase. The pieces are there, and at this stage in the study, it's really about creating definitions that are important for your product system, setting the limits from which you will operate, and coming up with that precise focus that you'll use in defining your scope. Here are some extra bits of information that might help make it easier to define your system boundary with respect to your scope. First, Ideally, you should be modeling your product system such that the inputs and outputs at the system boundary are either elementary or product flows. If that statement confuses you, go check out the terms and definitions video from this series. All four of these concepts, product systems, system boundaries, product flows, elementary flows, they are explained there in detail. Alright, so if you're with me on the language, you'll see that intuitively this step makes sense. It helps ensure standardization and normalization as the study moves deeper into the analysis phases. It also makes allocation steps a lot more straightforward. That's another important term that you can find in our previous video. Secondly, as we move on to those analysis phases, if you decide, for example, to eliminate the impact assessment phase, right? Turn the LCA study into an LCI study. Or maybe you decide that another phase isn't even necessary, or subsections of a phase that are otherwise recommended by ISO. Let's say in your case you're going to skip them because they just don't apply to your situation. If you're going to remove stages, processes, inputs, outputs, whatever from your study, from your system boundary, that's only permitted if you do not significantly change the overall conclusions of the study. In any case, any decisions to omit these should be clearly stated and documented, along with the reasons for their omissions, which should themselves be explained thoroughly. And also, any implications you expect from having removed them. You'll have noticed at this point a theme of transparency and completeness when it comes to the LCA, starting even at this early phase. Based on our previous time together, I don't think this is much of a surprise. So, even in this early point in the study, remember that everything needs to be documented. Finally, let's return, as I'd mentioned, to the cutoff criteria. If you do include cutoff criteria for entry into your system boundary, you need to include the assumptions you made to arrive at these criteria, as well as the effects of these criteria on the study that you would expect to see. Think back to our restaurant example. We're still interested in natural gas consumed per plate of food served. That's our reference flow derived from our functional unit. Now, say we want to include a caveat. Let's say we're going to hyper-focus on the natural gas consumed by the food appliances themselves. So that means we're going to look at the stove, we're going to look at the broiler, but we might ignore the heaters that we have out on the porch, for example, keeping the guests warm in the winter. They may still consume natural gas, but now what we're saying is the extent to which we expect that volume or that rate of gas to affect the study is unimportant, or it's negligible, or we just don't care. Or a second example, maybe we're just going to ignore all of the gas meter readings from the month of December, right? Maybe we're not open for 2 weeks that month, and another week we're just doing prep and cleanup. Another week is employee events, and altogether we're only open, 5 or 6 days out of the entire month. So we're saying December isn't representative of the standard operation of that restaurant, and so we're just going to ignore it. You are allowed to do this. Whatever the circumstance, whatever your decision is, and whatever justifications you have for reaching those decisions, document them. You might be right. They may be negligible considerations, and the study doesn't suffer from omitting them. But you might also be wrong, and later on, weeks or months later, we might need to add those considerations back into the picture. Regardless, one way or the other, keep them documented. Get them on paper for posterity and for reference. Just for your information, ISO provides 3 examples of important cutoff criteria. They're the following. Mass. This is when you include all inputs that cumulatively contribute more than a defined percentage of the mass input to the product system. Contributors that fall below that cutoff are discarded for the purposes of the study. A second example is energy, which follows much the same idea. Which inputs provide more than a defined percentage of the overall energy in the system boundary to the system? If they're below that level, we discard them. So, say for example you're making plastic products, and most of your production effort goes into big, solid plastic pieces. They use up a lot of resin, a lot of inputs, right? They take a lot of energy to produce. And alongside those, you might have a couple of smaller customers. They order small pieces, the orders are very infrequent, you kind of do them, they're one and done, and you don't hear from them again. You might not consider those flows as part of your study. The volumes and the rates just might be too low for you to care or for them to make a difference. Finally, the third important piece of cutoff criteria provided by ISO is environmental significance. Which inputs contribute more than an additional defined amount of some estimated quantity in the system? So again, if your main processes create 10 times more carbon monoxide than your auxiliary processes, you may want to tailor your study to favor your main processes, to match that weighting of what is producing more environmentally significant effects than the other. This might actually be what gives your study more relevance than had you included absolutely every process in your production chain. This is the importance of a well-tailored scope. So, that's the video for the goal and scope definition phase. I hope you found it useful. Remember that this video and the ones that will follow it after, they will deal with individual LCA phases. They'll cover material that you can find in both ISO 14040 and 14044 standards. In this way, we'll learn a bit more about the process of actually setting up and carrying out an LCA with each new phase that we explore. I hope you'll stick around. I'm Jamie Friend-Okombo with EnviroPass. Thanks for watching.